Guys, it's Craig here from fixitfallows, and as you can see, once again I am in my garage, and I am in the garage because I'm about to unbox a new little toy that I bought myself. Now, I've been thinking about purchasing one of these for a little while. There are a few bits and pieces that I think I could put it to use for, and what this thing is a mini lathe. Now, when I say mini, this is particularly mini. I've never done any turning or metalwork like this before, so I will be making it up as I go along. I'm sure there's going to be fellas and ladies out there that are experienced turners, tool makers, machinists, whatever you want to call yourselves, who will look at what I purchased and scoff. Well, we all have to start somewhere, and for the scale of projects I intend to be using it for, I'm hoping that it will be suitable. Now, what I'm going to do is I am going to show you the unboxing. You can see what it is, and then we will maybe delve into a bit of how I can maybe adapt the machine to make it a little bit better than maybe it ships as. There's already videos out there that sort of show this sort of thing. I've been doing a bit of research, so I'm going to have a little go myself. So without further ado, let's have a look, shall we? So here you go then, guys. This is what you get in the box. You get the actual lathe itself. You get a power adapter because the motor in here works off 12 volts. So on this particular model I ordered the 60 watt machine, so it needs 12 volts and it runs at 5 amps, hence 60 watts. So you get the 60 watt 5 amp adapter, but you know, you could use any 12 volt or maybe even 18 volt adapter, outputting whatever ampage you want, and the motor will probably take it. It has a simple on and off switch on the power adapter, and there's like this jack plug connection that connects the power output to the motor here. There is no speed control when this gets shipped to you. It is either on or off, but that is something that I'm going to address with a little adaptation, which I shall show you in a second. The adapter there ships with either an EU plug or a US plug, so here in the UK that's of no use to me, so you can either just cut that plug off and wire on a UK plug, but as you can see, look, it's your bog standard connector that back in the day we used to use to connect to our record players, tape cassette players, and I just so happen to have an old one laying around. In fact, I've got loads of them laying around with a UK plug, so that will go straight in there and that's all good. So I can put this EU plug one to the side. You get a little bag of bits in there. You get metal bars for adjusting the chuck. There are a load of little hand knobs for going onto the adjusting points here and here. I'll get all those fitted on. There's an assortment of different screws and fittings because you can adapt this and move it around a fair bit. You also get a mounting plate. There you go, so bolts go through the bottom of that and connect with this, which I shall take care of in a minute. I believe this little thing here is for centering the your cutting piece, your cutting tool with the center of the chuck. I believe that's what that's for, but I'll find out in due course. And then there's some pads there to go on the bottom of the tray. I guess that just stops it vibrating around. So that's all good. Now, just to give you some indication of its size, it is small. There's no two ways about it. It is small. But that's perfect for what I need. And just to give you some sort of indication of its size, let me give you a point of reference. This is a 330ml can of Coke. There you go. If that gives you some sort of idea of the scale. Okay, What I would say to you is it is surprisingly heavy and surprisingly sturdy. Much heavier and much sturdier than I was anticipating. There is no slop that I can feel in this bed here. There's a little bit of give in these control knobs, which I've had a look at already, and that can be overcome. You could take up all that slack. There are washers in here that, when you do this nut up, become tight and make this tight, so arguably I could change them out for some thrust races. That would improve that situation. With regards to this motor, this can be slid along here. This is just in a format for the most sort of compact shipping purposes, so we can slide the motor back this way and the headstock can move that way, and it can all be moved around to whatever your needs are. This tall post you just undo there and you can move it around and put it on any one of these runners, but you know, that's all more finer details that we'll get into when I start playing around with it. So let's get this set up. On the base, we've moved the headstock over to the left, the tailstock over to the right, out the way. Okay, so one of the very first things I want to do is I want to change this cable here. At the moment it exits the machine to the front here, and I don't know whether it will, but I just feel that it could potentially just get in the way of working here. So what I want to do is make this cable exit out to the side. So at the moment this plate here has got a little cutout to enable the cable to come here. So what I'm going to do is I'm going to take this plate off, create this little opening like this but on the other side, so we can route the cable that way. So let's just get these 4 screws out, that plate will come off and I can do that, no problem at all. So there you go, there's the plate off, and as you can see it's just your standard 12 volt motor in there. I'm not sure if that's a 755, 795, 855, whatever the numbers are, but that's a pretty standard motor, so should you ever need to replace it, that's no drama at all. And as you can see, it's just a simple case of 2 wires, one to the positive, one to the negative, and I'm simply going to route the cable out to that side. So there you go, there's the original cutout, and I've just created a new cutout on that side. So we can just put the cable there now, put the plate on like that, and as you see the wire goes that way, like that. So here we are, this is the headstock. It's got a plastic cover over the back here that covers over the belt, the pinion on the motor, and like the spur pulley there. Also you can see the back of the shaft there that the chuck is ultimately connected to there. It is a hollow chuck, hollow shaft, and it has a bore of 7.4 millimeters. So that means you could have a long piece of stock like this, and you could pass it right the way through, and as you can see it's emerging there at the chuck, so you could tool a longer piece up to about 7 mil, 7.4 mil. There you go, it just gives you a little bit of extra scope. So let's get that plastic cover off. That's just a single screw there, and screw that, off it comes, and there you go, that reveals the back of the headstock. There's your pinion, I think it's an 11 tooth, and there's the sort of drive spur pulley there. I'm not quite sure the number of teeth there, not quite sure what the reduction is, but as you can see there on the motor, it looks like there's some adjustment, so you can adjust the tension on the belt. Yeah, looks like the spur is held on by a grub screw down through that hole onto the shaft, and I'm not sure about the pinion, whether it's just a push fit. Yeah, all these parts are available. You can buy the belt, you can buy the pinion and spur pulley there online. There you go, there's the code for the belt. It's a couple of quid, so it's all quite cheap to replace should you need to. I got this entire thing off of AliExpress, and needless to say, all the spare parts are available on there too. There you can see there's the tool holder. On this side it takes a 4x4, that's 4mm HSS bit, and on the other side of the tool holder it can take an 8mm by 4mm or 8mm by 8mm tool bit, like that. Okay, so here we are, we've got the lathe up on the workbench. What have I done? I have put some lubrication on all of the screws there, just to enable the mechanisms to work as best as possible. As you can see, I put the little finger knobs onto the handles there, and it all turns well. There's a little bit of wobble in this carriage here, but there are gib screws on the sides here that you can adjust to take some of that slop out. I don't think you'd get all the slop out, but there you go. Your tool post there is adjustable by an Allen key. You put that in there like that, undo it, and you can rotate it, slide it back and forth, and put it in any of these channels that you see fit. I say there's a little bit of play on these turning knobs here. They are quite well marked in terms of, I think they give you what is that, 0.04mm increments per line. Okay, so you can be relatively accurate, but there's just a little bit of play in there. Now I've had a little look, and probably the most effective way of taking that slop out is to drill a tiny little hole down through that red collar there, and put a grub screw down there, so that it then locks onto the flat spot on the shaft, because the shaft is a very small diameter. There is a corresponding flat spot on the bore of the handle, but they're so small, you know, there's a bit of play in there. So I think I will in time drill down through this red collar, put a little grub screw in there, and that will take care of all of that slop. So when you want to do, you know, one incremental turn, you will be as accurate as you can possibly be. Other than that, okay, at the moment I have put this one of these gauges in the chuck, and that just enables you to ensure that you've got your tool bit centered and at the right height. So I'll just position that like so, and bring the camera around to there. I can now see that my tool bit is dead center with the center of the chuck. Like that. So I've got the power unit connected up, and let's switch on the switch. As I say, it only has an on and off. There's no speed variation at this point, but I'll show you how it works. Let's switch it on. There we go. Okay, so the next thing to do is to try and introduce some speed control to the chuck, because depending on what material you're cutting, you want higher or lower RPM. Now to do that, I have got myself what's in this little box, and in this little box is a PWM, a pulse width modulator. Now what that does is it pulses the power to the motor. The longer the pulses, i.e. the longer it sends power for, the faster the motor spins, and the shorter the pulses are with the longer gaps, the slower it goes. I.e. what it effectively does is controls the amount of voltage going to the motor. I bought this off of AliExpress. I think this was about £5, and all I simply need to do is on the connection terminal on the back of this little unit, you have, what have we got? We put the power in, so I shall be basically making a cut in the cable from the power supply. I shall be doing it, what side shall I be doing it? I guess I could, well, it doesn't really matter. But you put your positive and negative power in, your positive and negative power out, i.e. the bit that goes to the motor, and then on this gauge here should be displayed the percentage of power that's going to this. It will not show me RPM, it will show me percentage of power. So if I'm giving it 12 volts, or supposed to be giving it 12 volts, and I've got it at 50, then it should be providing 6 volts. And I'll just be going by visuals and by sound as to what the RPM's actually doing. In time, I guess I could fit up a tacho to this so that I can actually see what the RPMs are, but to be honest, at my stage of understanding and skills of turning, I'm not going to worry, because at this very moment in time, I've never even turned a single thing yet, so maybe I'm getting ahead of myself worrying about the RPM. But yeah, gonna fix this up and show you the control I then have. Okay, so now what I've managed to do is I've managed to set up my speed controller to the lathe. So this, as I said, is a PWM, a pulse width modulator, and I got this off AliExpress. That's the code there, ZKBMG. So the input can be up to 60 volts and up to 12 amps, so that's more than sufficient for this lathe. For the moment I've just got that taped to there, but in time I will probably make something more permanent, you know, like a mounting plate or whatever. So just so you know, look, the motor cable comes out of there, runs around, and it feeds into the output side of this, and then the power unit there, like so, connects as per standard, goes into the input side of there, and then this will regulate the amount of voltage going to the motor and the speed of the chuck. So this is the adapter. I actually cut the switch out of this. I didn't have too much confidence in the switch itself. It seemed a little bit light, so I've just cut it out, as this actually acts as a switch. So let me show you. Okay, we'll connect the power up. We will turn the power on. Okay, so like this. It's going to flicker a bit because it's a digital readout, so apologies. But at the moment we have got power from the adapter that's going into this unit, but at the moment this little LED is not green, which means there's no power going to come out of here to the lathe. If I press the knob in, the green light comes on, and look, the chuck starts to turn. So you just turn the knob. If I turn it down to 7, the chuck doesn't turn, so the motor needs more power than that. And as we turn the knob round, the chuck starts to spin. So I can have it chuck rotating that slow, or I can crank it up. So that's now running at 50% of the voltage. Or I can crank it all the way up. To 100%. And then you just press the button in and it stops. So you can turn the percentage down even when it's in the off mode. So there we go, let's set it to 40% power, and there we go. Gives you speed control. So all that remains to be done now is to actually put something in there and actually try turning. It will be the first time I've ever tried it. Okay, so just for starters, I'm going to put this coach bolt in the chuck. I'm going to take this marker pen. I'm going to put a black spot there. And I'm going to put a black line all the way around the outside like that. And I'm going to see whether I can flatten this bit off, and you'll see that because silver will shine through, and I will reduce the overall size of the head, and you'll see that because hopefully the black bit around the outside will disappear. Okay. I think what I'm going to do is I'm going to put some tissue over these areas here to protect the lead screw and the runners from the chip-ins and filings. Now, I know real decent lathe machinists, turners, whatever, will want to get nice strings of metal. I suspect we might get lots of chips with this. I don't know the quality of the tool that they've sent me. I haven't got a clue what speed I should be running at. This is the first time I've ever tried this, so bear with me. Okay, so far we have taken the head of the dome off. You can see all of the black markers gone. That's definitely now a flat surface. For my first ever attempt, that's not a terrible finish. I'm quite pleased with that. Now let's have a go at taking down the diameter. what I've managed to do so far. So clearly I've taken some of the diameter down, I've taken the dome off. Now I don't know what I'm doing. I'm having a bit of a problem with the chuck, yeah, and this thread that this effectively wants to screw itself into the jaws, and I'm not quite sure how sharp this bit is, and there is definitely a bit of slop on this. You can see this move under too much pressure. The other issue I'm having is, because there is some slop in this, I can't sort of be accurate as to how much I'm moving it on each time, so I really do need to put some grub screws in here so that every movement is directly correlated into that carriage there. So you can see that I can move that much and the carriage doesn't move. So a grub screw on that will help, and I think that will help with controlling this a bit better, because at the moment I think I'm doing too deep a cut. I'm trying to achieve too big a cut each time, which, you know, I think that's a typical novice thing to do, being too greedy with a cut. Got to take your time, but fundamentally it is working. You know, there are some longer bits of schwarf there, not all just chip-ins, mainly chip-ins, but you know, I'm sure you professionals out there will have a few words to say about that. But at the end of the day, this machine is able to turn a bit of steel and will definitely be able to deal with aluminium and brass and plastics. Just as well as a comparison, this is what the bolt started out like, and this is what I've done to it. So very definitely a different profile. So there you go, there's my first ever bit of machining, and you know what, I was quite pleased with the way that went. The machine itself, I think it's alright. As I say, this is the 60 watt variant. They do lesser wattage ones. I think you'd probably be struggling with one of those. If you're going to get one of these, you might as well just go all out and get the 60 watter. Definitely worth putting the speed control on there, the PWM module. And I will definitely put in those grub screws on the turn knobs, because that will just give me that little bit more control. Hopefully will enable me to produce cleaner, better cuts. So in the meantime, I'm going to persevere with it, hopefully bring you some content that shows you that I've improved and I've made something actually worthwhile from it. But in the meantime, please be sure to like, subscribe and hit the notification bell, and check out some of my other videos. Thank you very much for tuning in, and I shall see you soon.